Hello everyone. So I found a formula and I'm really excited to share it to everyone. Okay, it's about a product of a geometric sequence. In this video, I'm going to explain what that formula is, how I found it, and I don't really know how it works for now, but let's say in the way that I found it, it's kind of like explaining how it works. Okay, on the purpose of those variables and constant in the in the formula. Okay, so here it is. Before we start, actually, I want to explain to you and tell you that this formula works only for finite geometric sequences, meaning that the geometric sequence that you're going to use should have an end term. Okay, and this is the reason for this is because I believe that if you have a geometric sequence and you try to like multiply all its terms from a sub 1 to a sub infinity, you'll end up multiplying a number to a number and to a number and to a number, which would either make it big or make it small. I'm not generalizing here. Maybe this is going to be an invalid generalization, but I'm just saying that it's what happens most of the time for integers, right? Okay, so it's what happens most of the time. You can correct me in the comment section if you want. I'd be glad if you'll do that because I'm going to become better if you'll make suggestions. I'll accept it if I'm really wrong. Okay, and let's continue. The formula that I found is that a sub the product of a geometric sequence is going to be equal to a sub 1 raised to n times r raised to the factorial of n minus 1. Okay, let's try it for an example. Let's say that we have this sequence with the terms 3, 6, 12, and 24. Well, we know that r is equal to 2, our a sub 1 is equal to 3, and our n is equal to 4, right? So if you try to apply this formula, you will get a sub 1 raised to n, which is basically 3 raised to 4, times r raised to the factorial of n minus 1, which in this case is equal to 2 raised to the factorial of 3, and that's going to be equal to 81 times 2 raised to 6, and in that case it's equal to 5,184. And I tried using a calculator in this example, and I found the same thing. It's equal to 5,184. Okay, and I'm going to explain how I found this formula. Okay, so I was just sitting one time a while ago. Actually, I found it a few minutes ago. Well, an hour now because I still made this PowerPoint. Okay, I was sitting somewhere and I was wondering why is it that in school they mostly only teach about sum of geometric sequences, right? Like why won't they teach about the product? Isn't there a formula for it? And I was wondering what's the pattern, and I found this, and I'm really glad because there are these people who are wondering in their minds about mathematics, about numbers, and then they end up having nothing. I experienced that a lot, and I'm really glad that I found something this time. Okay, I had this carton. I don't know what's the English term. I think it's carton as well. It's like a piece of a box. I don't know the English term. I'm gonna search it later. Anyways, it's just a piece of some sort of paper, but it's kind of I don't know what it's made of. Okay, this is it's like let's say a paper. Okay, it's kind of a paper, and I wrote formulas. I tried to observe the pattern of sequences, geometric sequences, and I found something, and I'm really happy about it. That's why I'm trying to share it with you today. Okay, so what I did is I have, for example, this sequence. I know that I shouldn't do this, but I factored out 3. Okay, I don't know. I'm just wondering in algebra if there's some sort of operation in here, this would be possible, but I don't know. Okay, I did that because I thought I found something, and I really did. So I'm happy about it. Okay, and I've also observed that in this, so I factored out 3. We got 3 here, 6, 12, 24. I factored 3 out. So basically, 3 divided by 3 is 1, 6 divided by 3 is 2, 12 divided by 3 is 4, 24 divided by 3 is 8. And I've also observed that 1 is equal to 1, of course, okay? And 2 is equal to 1 times 2. 4 is equal to 1 times 2 times 2. 8 is equal to 1 times 2 times 2 times 2. And what I found here was basically it's going to be equal to 3 prime numbers of 2. There are 6 here. There are 6 numbers of 2 here, okay? And that's equal to 3, or let's say the prime. Why am I saying prime? I meant factorial of 3. 3 factorial, okay? I was studying derivative a while ago. I'm kind of addicted to derivatives. So I'm saying prime. Sorry about that. And okay, so let's proceed. I found out that there are three factorial numbers of two. Okay, and I've because I the goal here, okay, to be clear, the goal here was to find the area. I'm sorry, not the area, the product of 1, 2, 4, and 8. So you're gonna multiply it. 1 times 2 times 4 and 8. But how do I make it in a fast way, right? What's the exact formula for that? I was wondering about that. And I found these numbers here. I found out that 1 is equal to 1, 2 is equal to 1 times 2, 4 is equal to 1 times 2 times 2, 8 is equal to 1 times 2 times 2 times 2, and I realized that there is some sort of similarity between this and factorial. And I found this, the three factorial numbers of 2. There are three factorial numbers of 2, which means that the area of this is basically 2 raised to the three factorial numbers of 2. Because there are three factorial numbers of 2 here. Let's just use 6, okay? There are 6 numbers of 2 here. Then I'm going to multiply 2 to itself 6 times. 6 times, okay? So that's why I found 2 raised to 6, or basically 2 raised to 3 factorial numbers. Sorry, 2 raised to 3 factorial, okay? So now that we've found and we've reached our goal to find the product of these numbers inside the parentheses, the next problem here is how am I supposed to multiply out 3 now that I've found the area of this? Do I like multiply 3 to this, or do I like multiply 3 one by one and one by one, you know? So what I've found here, okay, so what I did was the behavior of how this whole thing works is going to be 3 times 1. So that's one. That's one that's one times of three. No, no, no. Wait. Let me clear. Let me be clear. That's one. Okay. 3 times 1. That's one. 3 times 2. That's two. 3 times 4. That's three. If you're getting what I'm saying here, and 3 times 8 is that's four. So you've multiplied. Okay. Here's where I'm gonna be clear. You multiplied three to these numbers inside the parentheses 4 times, right? And therefore, you've multiplied it to 3 times 3 times 3 times 3. That is equal to 3 raised to 4. Okay? And what's in here? And that is equal to why do I act like I don't know what's in the next slide? Okay? And that formula is equal to r raised to n minus 1. Sorry, r raised to the factorial of n minus 1. I'm really too excited to tell guys about this, which is why I'm kind of nervous. Okay? So that's going to be equal to r raised to 2 minus 1. Wait, this is. Oh yeah, this is right. Wait. I'm gonna try it. This is wrong. Wait a minute. I'm gonna change it. It should have been a sub 1 raised to n, which is because you multiplied 3 to these terms 4 times, because there are four terms inside this parenthesis. So you multiplied it 4 times. That's equal to 3 raised to 4, or 3 raised to 4 here. That's going to be equal to a sub 1 times n, which means that this whole formula here, this is a formula. Yeah, it's kind of a formula. Formula is used to, like, you put something in input and output. Anyways, this is a formula here. You have to multiply this whole. Oh, it's an expression or an equation. If there's something here, let's use an equation. Okay, this equation here, you want to multiply it to this equation, right? Wait, where is it? Right, where is it? Where is it? Okay, so I've already tried it in this exact direct formula here. We have a sub 1 raised to n and r raised to n minus 1. Unfortunately, I didn't have a separate slide. I don't know where is it though. And that's it, guys. This is the formula, and that's how I found it. And that's it. Thank you for watching. And I repeat once again, if you have questions or some sort of clarifications about the formula, you can just put it in the comments. I'm really open. Okay, I want to be I want to be corrected by people in case I say wrong things, because it's just making me better. I'm not going to hate them, because why would I? They're trying to make me improve, right? That's what it means for me. So anyways, that's it. Thank you guys for watching, and I'm hoping that you guys have enjoyed this video, and I'm still really excited to upload this video, so I'm gonna go upload it now. Bye.